Hello and welcome to the Dataset Dynamics demo, Keeping Up with a Lot of Changes by Jürgen Umbrich and Michael Hausenblas. So we're going to have a look at the problem that datasets do change. We review solutions and then jump into the demo. In late 2009 we have right over 100 open datasets providing roughly 7 billion RDF triples interlinked by over 140 million links, which is good. But that's a rather static view on the linked data cloud. Datasets in fact do change as, for example, new resources are added and new links are set, or old stuff is deprecated or removed at all. These changes may happen because they're planned, like your datasets is available from the original data source, as in the Eurostat case. We might have to deal with inherently dynamic data sources, for example, Twitter. Stuff gets fixed or corrected due to quality reasons and a lot of other reasons you might be able to think of. Now, the key question is, how does a consumer of linked datasets, such as other datasets linking to it, or applications using it, and so on, learn when something has changed and what has changed? Now, one may wonder if there are not already solutions available, and indeed there are. If we look at that diagram where the change frequency of the dataset is shown against the change volume of the dataset, we see that for low frequency and low volumes, indeed one can use HTTP level caching, like for a single document, for example, fourth document, fourth profile, for example. And of course, someone can crawl a dataset, which is especially for high volume datasets applicable. However, there's also the live data from feeds and sensors and so on there. However, we see and understand that there is a gap that likely needs to be filled. During the linked data camp in Vienna these days, Jürgen and I, hacked together a demo which is essentially based on a very lightweight distributed setting based on void vocabulary and daddy vocabulary for the discovery, and a slightly extended atom feed that communicates the changes. Now let's directly jump to the demo. You can find it here at Google Code, daddy. Here's the overall setup. We have the DCM, the Dataset Change Manager interface, where you can register a certain dataset, unregister it, and view the list of current observations. Okay, we have two scheduled jobs there. So we have a dataset, in our case a very simple dataset 1 RDF document. Let's inspect that, what's in there. Okay, very simple RDF XML. Very nice. So the second thing we need here beside the dataset is a void description, basically describing that dataset, which is also provided either by the publisher or someone else, a third party, and essentially linking the dataset to a notification mechanism, in our case the atom feed. Now if we look at that atom feed that contains the changes, we see it is indeed a valid atom feed. If we look at it, we see it's just simple atom slightly extended with two new values for the relations. So one can, of course, for debug purposes, view this atom feed in any out-of-the-box feed reader. However, for the demo purposes, we've also developed the client-side so-called dataset change watchdog that basically implements the discovery via void and daddy, and then subscribe to that atom feed, and we see what has in fact changed. Okay, quite a couple of changes. So let's take one particular change here. Apparently here some data has been added. Okay, here 1 triple has been added and 1 triple has been removed. Now, a potential consumer of that dataset here, so here's the dataset, here's the consumer, can either directly subscribe to the atom change feed, which communicates the changes, add and remove of triples, or use the DCW, the watchdog, to consume the changes. One has to know that this is a very low-level implementation. One just learns about triples which have been added, removed, or updated. However, one can imagine that based on that simple update mechanism, change notification mechanism, one can implement higher-level communication means to learn more about the changes in the dataset. If you want to learn more about the dataset dynamics in general, visit the ESW wiki page, have a look at the demo on Google Code. We are happy to receive feedback or general discussions on public LOD mailing list. If you have feature requests or proposals for the further direction, there is a Google discussion group called Dataset Dynamics, and or follow us with the hashtags daddy and or linkdata on Twitter, Identica, and the like. Thank you very much for your attention. Looking forward to hearing